Hello and welcome everyone to AI 42. Now tonight is a special night here because unfortunately I have some bad news that Eve and Gosha cannot be with us tonight, but don't be afraid, they will be with us in our next session. But I also have some really good news here that we have Luis Quintanilla here with us. Welcome, Luis.
Thanks for having me.
Hi, how are you doing?
Doing wonderful. Yeah, really excited to talk to you folks about machine learning and .NET. So yeah.
Yeah, so some background here. So Luis, he is currently the ML.NET program manager at Microsoft, and his main areas of expertise are machine learning and software development. And in previous roles, he served as an analytics developer in the financial services industry, as well as an artificial intelligence consultant. And in this role, he helped clients envision how could they transform their business through AI and machine learning solutions. So, Luis, can you tell us a little bit about what you will be talking about here tonight?
Yeah, absolutely. So I will be talking to you about ML.NET, which is the open source machine learning framework for .NET. Now, maybe a lot of folks may think Python and machine learning, but no, if you are a .NET developer, there's other options, ML.NET being one of them, right? So I'm excited to tell you a little bit more about things that you can do with ML.NET and things that, how different people are using it. There are some of our users and different customers, and tell you a little bit about that, and also show you a few demos of it in practice.
Okay, that sounds very interesting here. But before we start off, we just have some introductory information here about AI 42. So see you in a while here, Luis.
Okay.
Yes. Yeah, so we had an introduction here to Luis Quintanilla, who is the ML.NET program manager for Microsoft. And now we just want to give you some introduction here to us, AI42. So the main motivation here for starting AI42 comes from the recognition that there is no really good starting material for getting into AI. So AI42, we are a strong team consisting of 3 Microsoft AI MVPs that will strive to provide you with a valuable series of lectures that will help you jumpstart your career in data science and AI. So the way that we do this is that we want to provide you with the necessary know-how so that will help you to land your dream job, as long as it's related to data science or machine learning. And the concept is quite simple. It involves professionals from all around the globe that will explain to you the underlying mathematics, the statistics, the probability theory, data science, and machine learning techniques. And this might sound like a lot, but don't worry, because we will guide you through all of this. So all you have to do is to follow our channel and enjoy the content every second week. So it will be filled with real-life cases and also expert experiences. And, we have all started from scratch, and we are very happy to help you build it up from there. And you can always stop and rewind the videos or ask for clarifications in the comment section. And we hope to assist you on this wonderful journey and have you as a speaker one day. And we believe that by creating cross collaborations with other organizations, we can give the best opportunities to broaden your network in the AI and data science communities. And with the combination of our offered services, we would support less fortunate people and organizations that are not that recognized yet, even though they would deserve it. So AI42 is sponsored by Microsoft and Miles, and we are very humbled by all the support we get from our contributors as well. So we would like to thank Levente Pongor for all the beautiful graphics that you can see in our show, and Mina Marie for all the cool intro music before our events. And we're also in close collaboration with C# Corner and the global AI community. So our lectures will be available also on their YouTube channels in addition to our own media. We would also like to thank Nicolette Toth that creates and reviews all our text content we use on our website, on our advertisement, and also during our sessions. And you can also follow us here on Facebook, on Instagram, and on Twitter to become a part of a growing community where we will share knowledge and fun. And you will find every information that will bring you to an advanced level in the field of AI and data science. You can also watch our recorded sessions on our YouTube channel, and you can find our upcoming sessions here on our Meetup page. So you can scan these QR codes to get to the YouTube channel and also our Meetup page. We would also like to talk here about our code of conduct. So our code of conduct outlines the expectations that we have for participation in our community, as well as the steps that are needed for reporting unacceptable behavior. And we are committed to providing a welcoming and inspiring community for everyone. So be friendly, be patient, be welcoming, and also be respectful with each other. So with that said, we will get back to the studio. So hello again, Luis.
Hey.
So is there any prerequisite that people need to know of before we start, or any links or anything?
Yeah, let me actually paste it in the chat. I'll also be sharing them in my slides, but let me just paste it into the chat so you can share with folks. And this contains a lot of resources around ML.net, whether it's documentation, our samples repository, as well as the different extensions and software that I'll be showing off here and tooling that I'll be showing here. So with that, that's pretty much it. Not a lot of prerequisites there.
And also for the viewers, please feel free to ask questions here in the chat, and we will both answer them on the ways, and we will also have a Q&A session here after Luis is finished with his presentation. So with that said, I would like to give the stage here to you, Luis.
Great, thanks. All right. Well, thanks so much for that awesome intro. It's really great. Seeing the points and some of the things that you're trying to do here with AI 42. In a lot of respects, right? It kind of aligns with some of the things that we're trying to do as well with ML.net. So that's awesome. But anyway, I'm here to talk to you folks about machine learning for .NET developers. My name is Luis. I am the program manager for ML.net, which is the framework that I'll be speaking to you about here in a few minutes. I've been at Microsoft for about 3 years, started working in content, documentation, things like that, working on products like ML.net, Azure Machine Learning, and .NET for Apache Spark. So for me personally, I'm very, very passionate about this intersection of the .NET space and machine learning, right? So where both of those worlds collide, that's really where my passions lie. Let me just get into some of the things that I'll be talking to you about. I'll start off by talking a little bit about the machine learning workflow and just in general, what is the relatively standard process that most folks go through when they're building machine learning applications. Then I'll talk to you a little bit about why .NET, right? Often folks tend to make the connection that machine learning is Python only or maybe R only. And I'll show you that .NET is definitely a really great alternative for building machine learning applications and just applications in general. I'll tell you about what ML.NET is, things that you can do with it, who's using it, and then last but not least, I'll show you the roadmap. And in between, I'll also be showing you a few demos of ML.NET in action. So with that, let's get started. So the steps that you see here outlined in this slide typically are the general workflow or the series of steps that you typically go through and the process that you go through for building machine learning applications. All right. And typically these sort of different steps in the workflow are you can kind of like divide them into model training and model consumption. Training part, that's sort of when you're using data to try to build a machine learning model. And then the model consumption is once you have this model, this asset that can make predictions about unforeseen data, you go ahead and you deploy that and you actually use it to make predictions, right? So let's take a look at model training first. You typically start off with a problem and trying to understand whether machine learning is even right for you, right? So let's assume that you have decided that machine learning is something that you're going to want to try to use to help solve your problem. So the first thing that you're going to need is data, right? So you want to go ahead, get data, gather that data. so that you're able to start exploring it, seeing if it can tell you interesting things about the domain space and problem it is that you're trying to solve. Once you have the data, you want to prepare that data, right? So you want to apply transformations, and you want to get it in a state that a algorithm can actually perform operations on, right? So part of preparing the data, chances are that your data is not going to be clean. Oftentimes, when you pull data, when you're maybe doing tutorials and things like that, the data is relatively clean. But in the real world, chances are that you're going to have duplicates, you're going to have missing values. So those are things that you're going to have to deal with in this data preparation phase, which is actually one of the key components of this entire workflow. Because if you start off with bad data, then chances are that down the line, you're going to end up with a bad model that's not actually going to be able to make predictions or tell you anything about the problem it is that you're trying to solve. So it's really important to take a good amount of time in this data preparation step so that your data is able to, so that your model is able to sort of reflect and find patterns that are accurate, right? The other part of why you need to prepare your data is because, as I mentioned, you need to pass this data to some algorithms to train a machine learning model. And for example, if you're doing something like sentiment analysis or image classification or whatever it may be, computers don't really know how to interpret those things, right? They don't know positive or negative. They just know, numbers. And as a result of that, that's kind of why you have to prepare the data. You have to convert your data, if it's in textual format or whatever format it's in, you have to get it into some numerical format that you can then apply mathematical algorithms to, right? And that's where the training phase comes in. Depending on your problem, you're going to choose an algorithm that best suits that particular problem, right? So for example, you might be doing regression if you're trying to predict a numerical value, or you may be doing some sort of classification algorithm, logistic regression, if you're trying to classify or categorize items. The algorithm that you choose is going to depend on the particular problem that it is that you're trying to solve, whether it's you're trying to categorize things or forecast or predict some numerical value. But it's in this training phase that you pass your data to this algorithm, and the algorithm tries to find patterns within your data and tries to build a sort of model that is able to represent the domain space that you're working with, and then going forward is able to make predictions on new data, right? Now, once you have your model trained, you want to make sure that you evaluate this model. And in the evaluation phase, you're going to use different types of metrics, again, depending on the algorithm it is and the problem that you're trying to solve, to try to determine how far off are you from your ground truth, right? And that's really important because you want to make sure that you're as close as possible to predicting as close as possible to predicting to the actual values. Something else that you should probably consider in this evaluation phase is how easy is your model to train, right? So for example, if it takes you, 6 months to train a particular model, and you get a pretty good measure of, a goodness that a model is good, that's great. But if you could train a model in 2 weeks and it gave you almost the same accuracy or it was just as good as that model that took 6 months to train, right? Maybe a model that the model took 2 weeks would probably be better, right? In that regard, because it's easier to train and it's not as expensive or time consuming. Which leads me down to this other consideration that you should have when you're evaluating models, which is the aspect of trying to starting off with simpler models. And the reason for that is, number one, as I mentioned earlier, it might take less time to train, but also it might be easier to explain, right? So the more complex that your model gets, the harder it is to explain. And, if this particular model is making sort of decisions that influence or impact people's lives, right? You want to make sure that you're able to explain why the model is making the predictions that it's making, right? So there's a few things that you need to take into account when you're evaluating a model, and whether it's something that you then want to sort of move on and progress into the next phase, which is the model consumption phase. There's a few arrows here that you may notice, and that's because this is an iterative process, right? As I mentioned, you might have these metrics that aren't good, right? And whatever good means to you, it's going to depend on the scenario. But based on that, you might have to go back and either get more data, transform your data in a different way that better represents the state or the model that the domain that you're trying to sort of model. and whatever it is, right? So it's an iterative process that you go back and forth on until you reach, sort of that state where you have the model that's right for you. But assuming that you have the model, right, which ends up being typically some sort of serialized file, and that contains or holds state of, the patterns that it learned during the training process, you take this model and you go ahead and you deploy it. Now, typically this is done through as a web service, but essentially you just deploy it to some sort of end user application, and you use this model and give it new data then for inferencing and to make predictions on new data, right? Something you're going to have to sort of think about is this is not really where you're done. Very similar to the model training process or a series of steps. The model consumption is also an iterative process, right? So it's very possible that your model after some time is not going to reflect the state of the world. So one example I like to use is, imagine if you were maybe a hotel chain or some sort of airline company in late 2019, right? And you were trying to forecast for 2020, what your demand was going to be, right? How many people were going to go to your hotel? How many people were going to fly on your airplanes? And then global pandemic hit, right? And maybe you had a model that had a forecast that was telling you certain numbers, but now nobody's traveling, nobody's staying in hotels. So now your model no longer reflects the state of the world, right? So what you have to do in that case is go back to the model training phase and iterate on it until you can, represent the state of the world as it is now, within your model. So again, there's probably a little bit more involved in here, but in general, this is typically the process that you often go through when building machine learning applications. Now, how do people usually build machine learning applications? And as I sort of alluded to earlier, folks often tend to think of Python as sort of Python or even R as the languages that you tend to use for machine learning. And that's relatively true for the most part. You see here, this was a survey done by Anaconda, which is an organization that basically provides an ecosystem and different tools for doing data science and machine learning. And you'll notice here that 63% of the respondents said that they always or frequently use Python. And you can presumably, extrapolate from that they are using it in the sort of data analytics and machine learning space. Because again, this is a sort of a company that focuses on that. And then you see SQL and R not too far behind there. The folks over at JetBrains did a survey on what do people use Python for the most, and you're going to see that 2 of the top 5 were machine learning and data analysis. So again, reinforcing that point that Python tends to be the language that is often used. When folks were asked, what are your favorite Python features? There's a few of them here, right? So one of them was the simple syntax and the syntactical sugar, that it was easy to learn, right? So it's very easy to read, very easy to learn, easy to write, easy to read. It's a high level language that you can use for a lot of things. It had things like list comprehension and generators. There's libraries for any problem, and then they like the dynamic typing or the duck typing from a language level, right? So okay, this makes sense, right? These are a lot of really great things to have. But then if you look at what are some desired Python features, you see things like static typing and string type hinting. You see things like performance improvements. You see better concurrency and parallelism, pattern matching, and an official compiler, right? So if you take all that into account, right, you might, why am I even talking to you about .NET? Why am I talking to you about .NET and machine learning? And one of the reasons is, and here I'm showing an example of F#. And this example, it's not doing anything too fancy. It's just has a few functions here that are downloading HTML and then extracting the links from an parse HTML document. So nothing too fancy going on here. But you'll notice that some of the things that are here are combine both the like features, the things that people like most about Python, but you also get things that they desire, right? So for example, if you want to do dependency management, this is inside of a script. This is basically how you would reference packages, right? Go to NuGet, which is the package manager for .NET, or sort of the package repository for .NET, and then just pull down this package for me, right? And that's kind of how you do dependency management, at least in the script and notebook type environments. You get static typing, and you actually get the best of both worlds, right? So you get static typing where you actually have a compiler behind you that's checking your code. But at the same time, with languages like F#, you have really strong type inference. And what that means is that you don't have to tell it your types based on the logic inside of your functions or your code. It's able to infer, or it's able to guess what the types are. So you get that sort of duck typing or dynamic typing aspect, even though it's not dynamically typed, it's statically typed. So you kind of get a little bit of the best of both worlds there. You have features like pattern matching here, exhaustive pattern matching for that matter, things like list comprehension, and then you have things like concurrency and parallelism built in, right? So from that standpoint, as I mentioned earlier, right, .NET from a language perspective, you're able to sort of balance both of those worlds, both the light features, at least a good amount of them, as well as some of the desired features that Python has, right? And that's just from a language perspective. If you look at it from a sort of a unified platform and what can you actually build with .NET, you literally can build whatever you want. So if you want to do desktop applications, you can certainly build those desktop applications. If you want to build for the web or the cloud native applications, microservices, that's definitely an option for you as well with frameworks like ASP.NET Core. If you want to do mobile, right, you can certainly do that. So use the same tools, use the same sort of languages like C# and F# to build applications with Xamarin, which now it's going to be Maui, that sort of unified platform there for building these client apps. Gaming is also something there, right? Maybe things like Unity, and all different types of sort of gaming engines, right? You can definitely use C# and .NET set of languages and tools for building games. And one that's actually particularly interesting for gaming is that these same gaming engines could definitely be used in scenarios like augmented reality or virtual reality, right? So that's another interesting scenario that this gaming concept sort of extends to. IoT, you can certainly do that, right? You can run .NET on ARM devices. So that's an option for you as well for those scenarios where you need to sort of deploy and run applications at the edge. And then last but not least, you have AI, right? Which is what I'm going to be talking to you a little bit about. And the super interesting thing about AI is that basically you can run AI models that you train in .NET with tools like ML.NET, which I'll be talking to you about, across all these different sort of application platforms, right? So you can run it on the desktop, you can run it on the web, run it on mobile, run it on IoT, right? So basically ML.NET runs anywhere that .NET runs, which is really great, right? You're not confined to only a subset of sort of scenarios. You can really put these models and build AI applications as close as possible to where your customers or your users are. So with that, I keep mentioning ML.NET. So what exactly is ML.NET? Well, it's an open source and cross-platform machine learning framework for .NET. It actually started at Microsoft, I think now 12, maybe more years ago, under the name of TLC, or the Learning Code. And it was used internally at Microsoft to build all sorts of sort of machine learning applications inside there. And eventually in 2018, it was decided, hey, let's go ahead and let's open source this. And eventually that's when ML.NET was released, right, in 2018. I think version 1.0 was in 2019. So it's relatively new from an open source standpoint, but it's actually been around for quite some time. ML.NET offers different experiences, and you don't have to sort of pick and choose. You can sort of like move back and forth between them as you see fit, and wherever you see more comfortable, wherever you feel most comfortable working in any of these with, right? So at the very bottom here, you're going to see there's the ML.NET API. So that is the set of libraries and sort of core APIs that are under typically the Microsoft.ml NuGet. And basically this just provides you all the things from loading data, transforming your data, training models and selecting trainers, evaluating those models, and ultimately consuming them, right? So this provides you sort of that code first approach. If that's the way that you want to go, you can basically do everything inside of these ML.NET APIs, right? A step above that are the Automl.NET APIs. And AutoML, as the name sort of implies, is automated machine learning. And automated machine learning, what it does is it really helps two cohorts. And it's sort of that loop that I sort of showed earlier in the training process, where you're sort of getting your data, preparing your data, you are training a model, and then you're picking the best model and evaluating it to choose the best one. it sort of automates those iterations, right? So you don't have to manually try out different algorithms. So you don't have to manually, do all these things. AutoML will automatically do that for you, right? And two really good use cases for AutoML are, number one is if you are a beginner and you don't have a lot of experience with machine learning, AutoML can sort of help you get started and try to find, okay, here's something that works well enough for my data set, right? Without having too much effort there. As well as if you're an experienced practitioner, right? If you are an experienced practitioner, you kind of know what works, but you also don't want to manually just sort of try all these things. You can leverage AutoML to sort of help you speed up that iterative training process, right? And AutoML.net, those APIs, they're also a code first approach, right? The difference being is that instead of you actually doing all the transformations and selecting the algorithms and the hyperparameters and things like that, AutoML is doing a lot of that for you automatically, right? And then last but not least, you have the tooling. So that's Model Builder and the ML.NET CLI. Model Builder, which I'll be showing you later, is a Visual Studio extension. And basically what it does is it leverages AutoML inside of Visual Studio to train machine learning models for you. And it has this graphical user interface that walks you through this wizard-like series of steps that for the most part align with that machine learning workflow that I showed you earlier. And you're able to sort of, get a model and prototype things in no time and get up and running fairly quickly. And then that's for Visual Studio. So that's Windows only. Now, if you're working cross-platform, if you're working on Mac, Linux, and even Windows, if you wanted to, or if you're working in sort of these sort of CI/CD type scenarios, you're maybe using ML.NET as part of some sort of build system to sort of automatically train your models and retrain your models, then the ML.NET CLI is a really good option. It's a .NET Global tool. And as the name sort of implies, it's just a command line interface, very similar to Model Builder that leverages AutoML to train machine learning models for you. So again, ML.NET is built for .NET developers. You can stay in the .NET ecosystem using the existing tools like Visual Studio, like .NET CLI, as well as the languages C# and F# to build machine learning applications and integrate these machine learning applications into your existing apps, which I showed. You can basically build any type of app that you want. Although it's helpful to have data science experience with tooling, right, like Model Builder and ML.NET CLI and AutoML, the data science ML experience is not required, at least to start off. And yeah, so that's important there. And then last but not least is it's very easy to go from experimentation to production with .NET, right? And this is actually a really important point. That same survey that Anaconda did, the state of data science, they asked some questions from folks around getting to production, right? And I believe it was something like 28% of folks don't get into production, right? So they maybe train a model, but they don't actually get into production. And of those that do get into production, some of the major pain points were things like dependency management, things like having to rewrite what they had done into some other language, right? Presumably Python or R to something else, and vice versa, right? But if you're doing everything in .NET, right, your full pipeline end to end, getting your data, loading your data, transforming your data, training a model and deploying this model to a .NET application. If everything is done in .NET, right, there's none of that rewriting, and you can basically, again, use the same tools, use the same languages, and use everything that you're used to release applications, making it relatively easy and quick to go from that experimentation standpoint all the way to production. So what can you do with ML.NET? Well, you can train custom machine learning models, right? So that means that you take your data and you apply algorithms to this data based on the problem that you're trying to solve, and you train a model that is, again, customized to your data set, right? So picking the best model for your data set. You could also consume pre-trained models. Now, what this means is, as I sort of mentioned earlier, there's no denying that a lot of folks are using Python, right? And Python is definitely a dominant platform, and even R, right? Dominant platforms for machine learning. And that's fine, right? But chances are that maybe the applications that you're looking to deploy to, it might be a desktop application built with .NET, or it may be a web service that's running on .NET, right? So what exactly do you do in those scenarios? Well, with ML.NET, we make it very easy for you to take those models that have been trained in other frameworks like TensorFlow, and you can consume those pre-trained models inside of .NET applications, right? So TensorFlow, again, as I mentioned, is being one of those scenarios where you're able to consume those pre-trained models. And then we also work with Onyx, the Open Neural Network Exchange. For folks who may not be familiar, Onyx is this sort of standardized format for defining and serializing models. And what it allows you to do is if you train in one framework, say, for example, PyTorch, and you convert your model over to Onyx, you can then consume that from any other framework that supports Onyx. In this case, right, if you were to train in any of those other frameworks like Scikit, PyTorch, convert it to Onyx, you can then bring that model and use it to make predictions, right? So that model consumption step, you can do that inside of .NET using ML.NET. All right. Here are a few of the sort of different scenarios and different types of models that are supported inside of ML.NET. To the left-hand side here are some of the classical machine learning type of algorithms and problems. So things like classification, again, that's categorizing. Things like spam, not spam, regression. You're trying to predict a numerical value like the price of a home. Forecasting, as the name sort of implies, you're trying to predict a time series values, in the future. Anomaly detection, you're just trying to find things that look odd, look weird, like maybe there's energy spikes or demand is extremely high on your servers, whatever it may be. You have things like ranking, which that's kind of like if you're browsing on, say, Google or Bing, giving you the sort of the best or most relevant results, right? And ranking those results into something that makes sense. Things like clustering. So if you have a series of customers and you want to sort of segment them based on different characteristics and similarities that they may have, that's kind of where clustering comes in. And a recommendation, which is one that I think most folks are familiar with, if you're shopping, you're doing some online shopping, or maybe you're using your favorite streaming service, there are recommendations that typically are associated with those services. But we don't only support those sort of classical machine learning scenarios. We also support deep learning scenarios as well. One of them being image classification, and the other one being object detection, right? So some of those are powered by Azure, because typically these scenarios tend to be a little bit more resource intensive. You generally have to use a lot of data, and they also require more resources. So as a result, we also offer the option for training on Azure, right? Okay, so who is using ML.NET? So the top row here I'm going to talk about are essentially some of the internal teams inside of Microsoft that are using it. For example, Power BI is using them for their first aggregating customers and doing some sort of clustering of their customers. The Microsoft Defender, they're using it to detect threats ahead of time, right? So they're training a machine learning model. They're getting millions of threats at once. So they're using ML.NET to try to identify, whether it's scanning files or whatever it may be, to detect those security threats before it's even a problem, right? So they're able to process, thanks to machine learning, they're able to sort of scale out their efforts in defending your computer and your systems. The real estate and facilities management group at Microsoft, they are using this in the sense that they have these IoT systems. They have these different HVAC systems and sort of smart buildings that they control. So they have all these devices throughout all the different buildings at Microsoft worldwide. And what they use it for is, typically what happens is these systems are sort of logging telemetry. And this telemetry sometimes will sort of result in spikes or errors, right? And now, if it was just one device or a few dozen devices, it would be relatively manageable. But the number of devices is sort of in the thousands scale, right? So there's thousands of these devices. So these folks are using it, ML.NET, to essentially try to minimize the number of sort of false alerts or false alarms, so that they're able to sort of focus on the alarms that are actually actionable and that they actually need to go and investigate and resolve issues on. Right. So again, it's that sort of scaling problem where AI is helping them. Now you have external customers, right? So folks like Evolution Software, they're using it for Hazelnut. For preparing hazelnuts for market, right? Typically, that process is very error prone, and typically it's done by sort of gut feel, right? So what the folks at Evolution Software did was they went in and they placed these devices and created a mobile app that is able to use and create a machine learning model that's able to detect when the right moisture levels have been reached inside of these sort of dryers, and then it alerts whoever's managing that process that, hey, the hazelnuts are ready, so that you're able to have a little bit more consistency rather than sort of the inconsistency in the product that could potentially lead to a lot of revenue that gets lost there. The folks over at Camera Futura, they built some photo editing and photo processing software, and what they're using ML.NET for is for identifying images that are good. So often you may you go out and you take a bunch of pictures, and maybe in some pictures, maybe your exposure, right, it's too bright, or maybe there's red eye. There's all these things that sort of ruin your picture, right? So what Camera Futura has done is it's basically built an ML.NET a model with ML.NET and used it to detect what those bad features are, right? So that you don't have to sit there looking through your hundreds of thousands of pictures, trying to find the bad pictures, and Camera Futura sort of cuts down on that process and just picks out what the best pictures are, so that you can then sort of move on to the next step of processing and editing that. And then last but not least, AskGuard Systems. AskGuard Systems is using it to cut down on just waste in general. So they're using a machine learning model to forecast demand for their products, right? And basically one of the things that they've been able to do is they've been able to cut down on millions and millions of CO2 sort of emissions as a result of that, as well as reduce waste within different supermarket chains that they've been working with and implementing these models. If you're interested in learning a little bit more, there's a link here to the ML.NET Customer Showcase. It's also in the resources that I provided earlier. So if you're interested in reading about any of these stories or just some of the other stories that we have from our customers, you can certainly go ahead and take a look at that. All right. So with that, let me jump over to the demo. And while I'm pulling that up, I don't think I see any questions, but if there are any, I'd be happy to take them. Okay. So what I'll be showing you here is Model Builder. So the tooling and that code, that low code approach for building machine learning models with ML.NET. Now I'll start with a relatively simple example, or relatively, it's a real data set, but it's the taxi fare data set. Basically what I'm trying to do is, based on different inputs like how long a trip was, how far in terms of distance, how many passengers were in a vehicle, try to determine what the fare amount is for a taxi. So this is a regression type problem. And I'll be doing that with Model Builder here inside of Visual Studio. So the way they get started with Model Builder is, well, first of all, it's an extension, so you have to install the extension. But once you have it installed, you can simply go to a project here. In this case, it's a class library project. And you can right click on that and go to Add Machine Learning Model. Here, it's going to prompt you to provide a name for this asset called a mbconfig file. So it's going to have this mbconfig file extension. And let me just call it taxi fare. Now, what's going to happen is it's going to create a file here on the right-hand side. It's called taxi fare mbconfig. And you're going to see that this extension, this sort of wizard launched. And you can see here that there's a scenario, environment, data train, evaluate, consume, and sort of next steps, right? So very similar to that machine learning workflow that I talked about previously. Let me sort of bring this down here. You can see here that we have different scenarios. These are scenarios that we support with Model Builder. So data classification, value prediction, right? The image classification, forecasting, object detection, and recommendation. You're going to see here that there's also little sort of these labels here. The ones that say local mean that they're training locally on your PC, and the ones that say Azure means that they are you can leverage Azure to train these types of models. Right? In this case, because we're trying to predict the fair amount or a numerical value, we're going to select value prediction. And then we have to choose our environment. Now, in this case, because local is the only type of environment that you can train, meaning your local PC, that's the only option for us. But if you were able to train on Azure, right, you would see that option for you as well. Then it's time to select my data. So in this case, I'm going to select that taxi fare train data set. Let me just try to find the data sets real quick here. Train. Okay. So I'm going to select my data set. And what's going to happen is this data preview is going to show me a preview of my data just so I can spot check and see like, hey, does my data look off? Or is there anything, odd happening? So in this case, you have things like the vendor ID, the rate code, passenger count, trip time in seconds, the trip distance, the payment type, whether it was cash or credit card, and then the fare amount, which is the value that we're trying to predict. So based on that, we're going to go ahead here to this drop down and we're going to select fare amount as the column to predict, because this is what we're going to want to predict here. If there's anything that, maybe your data doesn't look right or it's not being done correctly, for example, let's say that you wanted to get rid of the header in this case, or maybe a model builder didn't detect the header, you can go to these advanced data options. You can specify things like that. Some of the things you can do here is you can ignore columns. You can determine whether a column is categorical, as well as select the data type if, again, model builder didn't identify the data type correctly. Similarly, again, there's that column header option where you can say, do I have a header or not, what the column separator is, and even the separator style, right, whether it's a dot or comma separator. But in this case, model builder did what was expected of it. So, it's fine. It looks fine to me. So we can move on to the next step. Now, in this next step, it's just going to ask you how long do you want to train for. Now, this is how long you train for is going to depend on how big your data is, and how much time you want to allow it to explore, because Automl will try to find, in the time allotted, is going to try to go and explore different algorithms to try to find the best model for you. Now, we don't have 10 minutes, so I'll just put it for 60 seconds instead, and I'm going to start training. You're going to see that there's a prompt here telling me, hey, you have a pretty large data set. Are you sure you only want to train for 60 seconds? And I will say, yes, I do. You're going to see that a countdown starts and the output window opens up here. And very quickly, what you're going to start to see here is all the different trainers or algorithms that that ML.NET or AutoML is exploring, along with the different metrics, how long it took to train that model, so on and so forth. One of the things that you'll see here is that there may be the same algorithm may be showing up multiple times. So, for example, I think, where is it? Light GBM regression is showing up here. Excuse me. Light GBM regression is showing up here multiple times, but the reason for that is it's not that it's actually trying the same algorithm multiple times. What it's doing is it's actually trying to identify what the appropriate hyperparameters are for this particular algorithm, right? So we see here that after some time, the top 5 models that it explored, where most of them were these fast tree or forest type sort of algorithms. And you can see that training completes. And the best model that it found was this fast tree regression model with an R squared metric of 91%, right? So it's pretty good. You're going to see that there's also this, it explored 33 models, and just overall, it took about 57 seconds to train, the whole training process. Something else that you'll see here is that there is this generated code behind, and there's this consumption and training. And if we open it here, you're going to see there's that consumption and training files. Now, what these are exactly, kind of what it sounds like. The training, basically, once your model is done training, code is auto-generated for you. Let me just close this here to make it a little bit easier to see, to build the pipeline. So Model Builder gives you back the pipeline and the series of transforms that it used to essentially transform your data and prepare your data for training, as well as the trainer. So you see, in this case, some of the transforms were on encoding. You can replace missing values. You can concatenate, it's concatenating the different columns into a single feature vector. And then it's using the fast tree algorithm, along with, you see all of these hyperparameters. It chose those automatically for you based on its training process. Right? Yeah, I see a question here. Can we predict more than one column? You cannot. You can only predict one column, and that's typically how it's done. Yeah, and there's different ways. So, for example, like if you wanted to, like, one of the things that you could do is you could sort of, like, let's say that you needed to use this prediction downstream, right? Maybe you could add another trainer here that used the outputs from this particular model and use that as input for your new model, right? And that's maybe a way that you could predict two columns, but generally you're often just predicting a single column or a single value with many of these sort of algorithms or scenarios. So hopefully that answered your question, Amir. Similar to training. So another note here for training and building the pipeline. So why does this matter? One is so that you're able to sort of recreate how this model was trained, right? If you wanted to to retrain this model later in the future, you can replicate how this model was trained on new data, but you can still use the same pipeline, right? So that's one of the reasons there. And then you have this taxi fare model consumption, which it has two things. One of them is this model input class, and this defines the input schema, so the different columns for your data set along with their data types. And then you have this model output class, which, as the name sort of implies, is sort of what comes out. And you'll see here that you have all of the columns that were part of the input, as well as the features column and the score column, this is the one that we're actually interested in. This one is the one that gives us that sort of fair amount predicted value, right? You're going to see here also that there is a helper method called predict, which basically creates a prediction engine for you, which is a convenience API for making predictions with ML.NET. You tell it that it's going to take in a model input as input and a model output as output. And you just call the predict method on that prediction engine given a certain input, and that's going to return to you a model output. So that's the code behind. Now, where exactly is a model? It's this zip file here. So again, it's a serial. Again, I mentioned that a model is typically a serialized, a serialized file that contains state, and that state is sort of saved in this zip file here. If you were to open this up, it's not very human readable. But yeah, basically all the information about the model is contained in this zip file, and that's what's being loaded in here and used to make predictions. So great, that's the code behind and everything that gets auto-generated for me. If I move on to the next step, that's the evaluation step. So we can see here that you have all the different inputs and you can sort of try to predict values. Typically, the value that's used here is the second column in our data set. So if we were to look at the second column here, we can see that the fair amount was 8, the actual number. And in our evaluation, we can see that the fair amount is 773. So pretty close. Right? What if we started playing around with some of this, right? Let's say that it took, I don't know, 200 seconds, or 200 seconds, right? So now the trip time, it's taking less time for this particular trip, right? So let's see what happens when we do that. So it makes sense, right? If you're taking less time on your trip, then the fair amount is going to go down. What if we were to bump this up to, I don't know, 30 miles, right? You can see that the fair amount sort of went up significantly. I mean, you must have been racing here because it took 200 seconds to go 30 miles. But the point is that it did what was expected, right? In terms of the trip got longer, so the fair amount went up. So great. Now it's time to consume it. Now you're going to see here that there's different ways to consume this model. If you already have an application, say for example, this class library that I have here, then you want to consume your model in. One way that you can do that is with, you can basically copy this code snippet, paste it inside of your existing application, and for the most part, you should be able to get a prediction using some of this consumption code behind that's already available for you, right? However, if you want to create a new application and if you wanted to sort of take your model and put it inside of a new application and sort of deploy it or run it that way, we have a series of options here. Number one, we have a console app. So again, if you want to, this is sort of a background process, or you run a batch job, whatever it is, you can use this model inside of a console app. We have the web API option, which actually uses minimal web APIs to go ahead and sort of make predictions there in the web, right? So you can deploy this as a web service. And then last but not least, we have these notebooks. So let me go ahead and open up the notebook. So these notebooks are very similar to something that you may, if you've worked with Jupyter Notebooks, It's very similar to it. The difference being is you're actually running .NET code inside of these notebooks. So let's give it a second to open up here. You're going to see here that it's giving me like the series of steps that it's going to do. It's going to define the model input, the iData view. It has all the different transforms, the algorithm, choosing the algorithm, training the model, evaluating, and consuming it, right? So these are all the steps that are sort of outlined and we go through inside of this notebook. Let me just run it all to kick off this process. You're going to see here that, first of all, in here, I am basically installing my different packages. In this case, ML, FastTree, data analysis, and Plotly for plotting. I am importing my packages. I'm creating that model input and model output classes as well, right? Providing the schema for inputs and outputs. You also have ML context, which is a starting point for all applications. You're defining how you want to load that data. You're displaying a few rows here whenever this eventually runs, right? That's the sort of the schema of my data. There's the first 5 columns in my data set, similar to that data preview we saw. But again, right, one of the things that I kind of want to highlight here is, number one, all this code was auto-generated for you, right? So you can take this notebook and you can run this code interactively, and you can even play around and tweak things as you see fit, like you would in notebooks, right? And sort of that workflow that you may be used to, and see the outputs and how things change in real time, right? Let's see, this is taking a while because it's actually training the algorithm. The other thing that I sort of want to highlight here is that this is a code first approach, right? So at the end of the day, this is using basically what you would do if you would otherwise have gone the code first approach, except in this case, you generated all of this through tooling, and it was all sort of automatically made for you. So there it is. It's evaluating the model. This might take a little bit of time to evaluate it, but it's basically going to show you what the statistics are. And then there's some plotting here that takes place. I'll give it a second to sort of go through all that. But in the meantime, I kind of want to show you something else that you can do. If we go over to, I think in the interest of time, I'm not going to train this other model. So I'll just kind of show you how it would work with the same taxi fare. So if I were to go to the web API and I were to add this to my solution, something similar happens. So let's follow web API 1 and then add it to my solution. So what's going to happen here, it's similar to the notebook that was auto-generated. A ASP.NET Core web API is generated for me. And if I open up this program.cs file, you're going to see that all the code, including my model here, this taxifare zip file, are sort of copied over to my new project, and I'm using it inside of now a fully functioning ASP.NET Core application. So in this case, I'm actually using minimal APIs, which was something that was introduced with .NET 6. And what minimal APIs allow you to do is they're very lightweight ways of building sort of web services. Now, this is a perfect scenario for machine learning, because typically if you're deploying, assuming that your model is sort of your model service and your prediction service is standalone, right? You typically just need a single endpoint to pass data into, make predictions, and sort of get predictions using your model on the web, right? So you can see here in this case, we're just creating a web application. We're registering the service called add prediction engine pool, which is the same thing as the prediction engine, except that it's threat safe, right? And can work in these scenarios where you're handling multiple requests, right? You have some boilerplate code here around Open API, and it uses Swagger to display sort of the endpoint information. And then last but not least, it's just this single endpoint, right? This is the one that we're interested in. So whenever somebody makes a HTTP post request to the predict endpoint, the prediction engine pool just calls predict, given a particular input, right? Taxifare model input, and then it just returns that value back to the user, right? If we were to just kind of run that, let me just right click, set as start a project. start my web API. I think we still have some time here. So what that's going to do is it's going to launch. Oh, or it should have launched. Not sure what happened there. Yeah, apologies for that. So what it should have done is it should have launched a ASP.NET sort of endpoint, and it should have that I can make requests against and test locally. Because this is just a .NET application, another really nice thing that I could do here is I can just right-click. If you're familiar with this sort of workflow in .NET, you can right-click Publish, and just go through this exact same workflow where you can publish to Azure. You can publish to a container registry, wherever it is that you want to deploy your application to, right? At this point, your workflows are exactly the same as those that you would go through for, whenever you're building web services or whatever type of .NET application it is that you're building, right? So from this point on, nothing really changes, right? You sort of go on about the same sort of general process that you normally do when deploying your applications. Great. So let me switch back here for a little bit to the notebook to see if this all sort of finished running. Okay, so here are the metrics and the statistics that are, sort of being shown here. Here is some plotting showing sort of the distribution. You can see that most things are taxi fares is between this $5 and $15 range. You can see sort of the distribution here. This one doesn't really tell you much, but you can sort of play around with the different columns here to try to get a visualization of how the different sort of X values or features sort of how they relate, their relationship to the fare amount. And then this other one column here, still running? Yeah, it's still running. So this one would essentially show you basically what the actual values are compared to the predicted values. And then this last section here, we also have explainability features in ML.NET. In this case, it's permutation feature importance, which what it does is it looks at your features and it tries to determine, okay, which of those are the ones that are most important, right? So, sort of by gut feel, when we were evaluating a model, we could tell like, okay, well, if my trip is longer, then it's going to cost more, right? But when you use features like permutation feature importance, you're able to actually, calculate how much that feature is impacting the predictions that my model is making, right? So that's basically it for the demo. I'll switch over to my slides for a second here to talk a little bit about the roadmap and some of the things that we're working on. So one of the things that we're working on is the Automl API and making improvements to it. So we're working with some folks over in Microsoft Research from the who basically built the NNI and Flaml Automl implementations, which are currently inside of the tooling, but you are not sort of able to use those same implementations inside of the framework yet. But part of these improvements that we're making to the Automl API is that you're able to get those same experiences that you're getting in the tooling inside of the framework. So you could have those code first experiences, get that sort of performance and different features that the NNI and Flaml implementations bring to you inside of this code first approach. We're also working on integrating with TorchSharp. If you're not familiar with TorchSharp, it is it's basically a .NET library for libtorch library, which is the sort of the core of the PyTorch set of libraries. Right. So we're working on some integrations so that you can consume TorchSharp, models, or, those PyTorch-like models, but also so that you can use TorchSharp to train custom models for things like natural language processing inside of ML.NET, right? And do that with a high-level API, think like a fast API or like a Keras, right? For training these deep learning models using TorchSharp. We're also trying to define our data preparation and data wrangling plan. We currently have the .NET data frame APIs available to us, but we want to make sure that those experiences are, improved. And yeah, if you have any questions or want to see more details about what's happening in our roadmap, make sure to check out this link. So I'll pause there. I think I finished just in time. And yeah, I'll take any questions if there are any.
Yeah, so thank you very much, Luis. Thank you for a wonderful presentation here.
Yeah.
So let us check here if there are any comments. I have a couple of comments here, so if the audience have any comments, so feel free to post in the chat here while we talk here. But my first comment here was regarding this taxi fare example. So I was wondering, because you mentioned here in the beginning that you were doing the training locally on your own PC, but you were also mentioning, is it possible to do the training instead in Azure, and what would that involve? What would you need to set up in Azure to make that happen?
Yeah, totally. So now with Model Builder, you can't do it with Model Builder. We only have the local scenario available. But if you were using, for example, the CLI, you can certainly leverage things like Azure ML to do the training for you. Using their CLI, there's actually, let me see if I can, it's part of my resources, but model and Azure ML. There's this blog post that we published a couple days ago, early this month, that shows you that process of using the ML.NET CLI to train models with Azure ML. Now, that's with the tooling. If you didn't want to use Azure ML or anything at all, you could definitely go that code first approach and just run a console app or whatever it is, right, inside of a VM in the cloud, right? And you can certainly go that approach as well. So it's super flexible in terms of whether you're using the tooling or whether you're using the code first approach with the APIs. It's really up to you. But yeah, you can certainly train on Azure. You just can't do it for this particular scenario of regression with Model Builder.
Okay. And then I also have another question here, because you were showing here that we could both write our code here both in C#, but you also had some examples here in F#. So what would you say? What is your advice? What would you use? When is there some particular scenario where you would use one over the other?
Yeah. So I personally, I really like F#. I feel like it gives me the best of both in terms of it's very succinct and lightweight, like Python, right? So a lot of those like easy to read, easy to write type of approaches. But at the same time, I have the static typing behind me all the time, the whole time, because it's .NET at the end of the day. But yeah, in terms of the auto generation that Model Builder does for you, it's all in C#, right? And we understand that sort of the C#, sort of community, it's a lot larger than F#. That being said, though, if F# folks would like to see more content or different ways that we can integrate F# into ML.NET, we'd love to see that. And you can use F#, right? For the most part, a lot of the code that you write, if you were to write the APIs, if you were to use the APIs for a code first approach, the F# code looks very similar to that of C#. So it's really a matter of preference, and use whatever, I would say use whatever you feel most productive in.
Okay. Yeah, thank you. Yeah, I think that actually concludes here the presentation here. So yeah, so if you please could stay here on the stream while we're finishing up. So we have some more information here from AI42. Yes, so we would just like to do some promotion here for our next session, where we will have Leon Gordon, who will talk about machine learning in Power BI. So that will be here in 2 weeks on April 6 at 5 o'clock Central European Time. So please stay tuned for that. And then, as always, we have an open CFP, an open call for speakers. So you can reach that on Sessionize, sessionize.com/AI42. So please feel free to submit your session on Sessionize. Then we would just like to take the opportunity here to say thank you to all of you who has been with us tonight, and to those of you who will be watching this on YouTube. And And we just would like to thank our speaker, Luis Quintanilla, for his great presentation here. And we're looking forward to seeing you in 2 weeks' time. Have a good evening.